Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are still continuing with inequalities. So today we are going to see how we solve compound inequalities. Maybe tomorrow we'll see how we plot simple inequalities, and then we'll complete this part of the course by taking some word problems and see how we create the inequalities, how we graph them, and how we find the solution out of this graph. Okay, so let's jump into it right now. Here we have like 12 pieces. I see that the ones on the right-hand side are harder, but we are going to go over all of them. So when we say compound inequalities, it's not like we say x is greater than 2 or x is less than -4. No, I give you the lower limit as well as the upper limit. So it's like they are two inequalities combined. So you can look at them as two problems. So I could have said 4 is less than 2x and solve for x and see x is greater than what, and then solve 2x is less than 12 and see what x is less than, and then combine them back. Or I can work on all of them simultaneously, which saves me time. Like when I look at the first equation, and they always, as you know, we start with very easy stuff. So we see that all these numbers are divisible by 2, so I can simplify by dividing all three pieces of the inequalities by 2. So I get 2 is less than x is less than 6, and I'm done. So x is somewhere between 2 and 6, can be anything between 2 and 6, but not 2 and not 6. Why? Yep, you still remember we don't have an equal sign. I didn't say x is greater than or equal to 2. I said x is greater than 2. I cannot change these except in two cases. One of them you won't see it in this course, but in only two cases, I can flip them over. Okay, you will see only one of them in this class, as I said. This one, similarly, I just want to have the x by itself, right? So I have x plus 2. I have added 2. What's the opposite of addition? Yes, subtraction. So now I subtract 2 from all three parts of the inequalities. I say -2, -2, -2. So I get the x by itself. -1 minus 2 is -3, and 7 minus 2 is 5. So x is greater than -3 and can be less than or equal to 5. So I can have x equals 5, but I cannot have x equals -3. And again, if you want to write that in, I would write this between parentheses 2 comma 6. And here I have a parentheses on the right-hand side and a bracket on the left-hand side, -3 comma 5. Okay. Let's move to the third one. I have x with 1.5 added to it, right? So, I'm sorry, 1.5 subtract. I want to say I have to add 1.5 so that these cancel each other. But if I add 1.5, I have to add 1.5 to all three pieces. So I get x is greater than or equal to 6.5, less than 10. And again, if you want to write it in this interval form, I would say 6.5 comma 10 parentheses. And now we come to the more important thing, which is the negative value. So if x is multiplied by negative something. Here, when you multiply or divide an inequality by a negative number, you switch the order. So if it's less than, it becomes greater than. If it's greater than or equal, it becomes less than or equal. If it's, unless it's equal, you don't change it, of course, right? But if it's greater than or equal, less than or equal, you change the direction of the inequality. So here I'm going to say to divide by -3, which is the same as multiplying by -1/3. Oh, Now I'm going to start backwards. I say the one on the right, which was greater than that, I would say 30 divided by negative 3 is negative 10. So negative 10 is less than or equal to x. Okay, so x now is greater than something, while here the negative 3 were less than something. The negative 3x, or now the x, is greater than or equal to 6 over negative 3, which is negative 2. Now x is less than or equal to negative 2. Notice that negative 2 is greater than negative 10. So it doesn't make sense to say x is greater than, unless you have two pieces. We'll look into that later. But when I divide by negative number, I have to change the great. This is x is greater than or equal. It becomes x less than or equal. X is less than or equal, so x is greater than or equal. So this goes here and that goes there. Okay, you can make sense of that. Why? Because if I say 5 is greater than 2, then negative 2 is greater than negative 5. When I multiply by negative or divide by negative and I switch and I say, well, this guy in negative form is greater than that guy in negative form. The other way, usually you don't see it in Algebra 1, but you may encounter it later, but there are ways to work on it, is that if you take the reciprocal, if I say 1 over x is greater than or equal to 5, then x is less than or equal to 1/5. If I take the reciprocal of both sides. Okay? And if I have both, then they cancel each other. Don't worry about that. So how is that possible? Yeah, if I say 3 is greater than 2, then 1/2 is greater than 1/3. Correct? But we will not encounter this case here. Okay. In fact, even if we encounter it, we don't need to think of that. You can do the cross multiplication, remember? So if I divide this by what I say 1 is greater than or equal to 5x, and then I divide by 5, so I get 1/5 is greater than or equal to x, or x is less than or equal to 1/5, which is the same. So I can do the cross multiplication. But if I know that the reciprocal, if I have x in the denominator, I can flip it over to the numerator, flip the other side, and then change the inequality. If it's greater than, I make it less than, and so on and so forth. We'll go over some of this stuff. So when we move to the next one, notice here, x is divisible by 5, right? It's divided. The opposite of division is multiplication. So I multiply all sides of the inequality by 5. By multiplying by 5, by the way, I don't switch anything because it's not negative. I didn't take the reciprocal. So I don't have enough space. So I'm going to say this whole thing is multiplied by 5. So the left-hand side becomes 15 is less than or equal. The middle side is x. The right-hand side, now x is less than 16. Again, I can write it as 15, 16. I told you, for some reason, the left-hand side is easier than the right-hand side, but in this one, I have two things. My x is multiplied by 2, and then I have a subtraction. So what do I do? What do I do first? Yep, I add 1. Some people say, can I divide by 2 first? Yeah, you can, but you are going to make it hard on yourself because you will get x minus 1/2, and then you add 1/2. There is no reason. Common sense would say these are separate terms. Every time the positive, the plus and the minus gives you multiple terms. Okay, so you take care of the pluses or minuses first so that you get only a single term. And then if this term x is multiplied or divided by something, you apply the opposite operation to separate it. So if I want to separate the x, the best thing is to take the -1 out and then divide by 2. You see the x stars. So adding 1 to all three sides, I get -2 be careful. I'm adding 1 to -3, not subtracting. -3 is down here. Adding meaning go up. So instead of being at the third level below, now you are only at the second level below, okay? Is less than or equal to 2x is less than or equal. Notice I'm adding 1 to 7, so it becomes 8. Next, I divide all three sides by 2, not -2, by 2. So I'm not going to change anything. This becomes -1, less than or equal to x, less than or equal to 4. If I want to write it as an interval, it becomes that. Next, oh, here I have a problem. The x is negative. So if I subtract 5 from all sides, it becomes -x. Oh, yeah, I learned I can divide or multiply by -1 and switch. You can do either first. So I can start by multiplying by -1 to make the x positive. So this would be x minus 5. That would be 1. That would stay 0, but I switch the inequalities, and then I would add 5. Or I subtract 5 first. It doesn't matter which one you do first. So let's say I'm going to subtract 5 from all sides. So -6 is less than or equal to -x is less than or equal to -5. And then I'm going to multiply or divide by -1. But what happens when I do that? Yes, the upper limit becomes lower and the lower becomes upper. So this would be x. This is less than or equal to 5, so it's greater than or equal to 5. This is greater than or equal to 6, so it's less than or equal to 6. Lower limit, upper limit. Okay? So far, so good, hopefully. Okay. So the daily error is not yet here. I didn't commit it yet. So wait for it to come. Same thing as this one, it's just a repeat. So I can subtract 1 first and then divide by -2, or if I divide by -2, that would be a fraction, and I already have fractions that would be even instead of 3. No. Just subtract 1. Subtract 1, subtract 1, subtract 1. The middle one is easy. It's -2x. The one on the left, I have -1 plus 3/4, meaning -4/4 plus 3/4 is -1/4. And -1 is -2/2. Why do I say 2/2? Because the fraction here is half, and here is quarter. So the one is easy, it's -2/2. 9/2 minus 2/2 is only 7/2. And then I'm going to divide all sides by -2. The middle is x. This one will come here. Notice 7/2 over 2 is 7/4. It's -7/4. That was less than or equal. It becomes greater. X is greater than or equal. And this one will come here. Negative over negative is positive, and 1/4 over 1/2 is an 1/8, less than 1/8. So it's -7/4, comma, 1/8, parentheses. So that was, these two were tricky ones because you need to divide by a negative coefficient, -1 here and -2 there, which switches the order of inequality. And then we had to notice, make sure that we do the subtraction of fraction. We learn how, still remember how to do that efficiently. Okay, here the 3 is multiplied. So I start definitely by dividing all 3 sides by 3 so that I can approach. Think of x is like, what? It's like you want to free the x. The x is inside the room, right? With 2 guards, and there are like 3 locks on the door. and you want to free the x. What do? First, you take the locks out. So anything attached to the room, to the door, is like a lock. So you have to free the locks first to enter the room. Oops, you see two guards. So you have to deal with the two guards first, and then you can free your x. So for those of you who like to play games and adventures, you can think of it this way. I found that it helps some. Anyway, so I'm going to divide everything by 3. What's wrong with this pen? It's okay, I think. So I have 2 plus x in the middle, greater than -3. Notice I didn't divide by negative. It was negative to begin with. I just divided by a positive, so I don't mess up with the inequalities. And then I subtract 2 from all sides. No, I don't use that anymore. So I'm going to subtract 2 from all sides. This would be, again, I subtracted, didn't multiply or divide. So this is -5 less than x less than or equal to 0. So -5, 0 is that. Okay. So next. Oh, here we have, again, combination of things. Okay. So first of all, I get rid of the 3 by subtracting 3. Why I start with the 3? Because I told you every time you see a plus or a minus, that's a separate term. You have to take, all the terms away and leave only the term that has an x, and then see how we reach the x. So here I have to subtract 3 first from all 3 sides. So that becomes -7 less than or equal to 3x minus 5 over 2 is less than or equal to 7 when you subtract 3. I have 2 in the denominator, so I have to multiply all 3 sides by 2. We won't have space here. It's too much work. 3x minus 5 is less than or equal to 14. Multiply every side. Oh, I'm sorry, -14. I told you it's coming. Okay. And then I have a -5, so we add 5 to all 3 parts. Left-hand side is -9 less than 3x less than or equal to 19. Then I divide by 3. Notice I divide by a positive number, so I'm not going to mess up with the inequalities. It's -3 less than x less than or equal to 19/3. Okay. So I can write it as -3, 19/3 bracket. Okay, now we move here. Wait, what? I have an x? So what do I do when I do that, when I have that? I think in this case, I can subtract x from all sides, but if I subtract x, it will jump and come here. So what do I do? If I subtract it again from here, it will show up here. If I add it here, it will show up there. So something doesn't work. How do I do that? Okay, so when you have this case, you have to separate these. The easiest way is to separate these into 2 separate inequalities. I'm going to say, okay, just forget about the less than or equal 19 and solve for this one. For this one, I have first to subtract x from both sides, not from all three sides, just from both sides, okay? So I will get -2 is less than 2x plus 1. And then I'm going to divide by 2. Oh, I'm sorry. I just subtracted. I subtracted x. Oh my God. And then let's say I also subtract 1. So this would be 2x, and this would be -3. And then I divide by 2, so I get x is greater than -3/2. And I stop. And then I go back here, and I say 3x plus 1 is less than or equal to 19. So I'm gonna, with a different color, probably subtract 1 from here, subtract 1 from here. So I get 3x is less than or equal to 18. And then I divide by 3 both sides. So I get x is less than or equal to 6. So I say x is less than or equal to 6. So it's as if I have two problems. We didn't have space, so I couldn't show you how well we did this part first. Subtracting 1, you get 3x is greater than -3. Divide by why did I say? Oh, yeah, we're subtracting x first. I'm sorry. Subtracting x, you get 2x is greater than or equal to -2. And then you subtract 1 from both sides to get rid of that. You get 2x is greater than -3. You divide by 2 both sides, so x is greater than -3/2. Then you go back and assume this is a separate problem. Subtracting 1 from both sides, you get 3x is less than 18. Dividing both sides by 3, you get x is less than or equal to 6. So now I have an answer that doesn't have x on either side. And of course, you would write, oh, I'm sorry. You do this as an interval. And last, it's the same thing, but the x is on the right. So I start with the left-hand side. So let's use this color for that. I'm going to subtract 1 from both sides. I'm not going to cross it out because later I will work on the right-hand side. I simply going to say 2x is greater than or equal to -2. I'm going to divide by 2 both sides. And I get x is greater than or equal to -1. Then on this side, I say 2x plus 1 is less than x plus 8. So I'm going to subtract x from both sides. And here I get x plus 1 is less than 8. Then I'm going to subtract 1 from both sides and get x is less than 7. And since this is x, so this is less than 7. And this would look like that, -1, 7. And that's it. Okay? So when you have a composite with x in more than one place, then you have to break those into 2 pieces. And then you can check for yourself. So for example, if x is -1, this would be -2 plus 1, which is -1. Yes, -1 is equal to -1, so it's okay. And if x is -1, you get -1 is less than 7, 8 plus x, so it's okay. If you do a 7, 2x plus 1 is 15, which is definitely greater than -1. But if 7 is x, then x plus 8 is also 15. And we are saying, we did something wrong. You have to check. Yeah, x is less than 7. It's not equal to 7. So this is 2x plus 1 would be less than 15, and the right-hand side is 15. So what is less than 15 is less than 15, right? So you can always go and back and check to see if that makes sense on both ends, that it satisfies all three parts of the inequality. So that's the end of it. And next time, as I said, we are going to see how we are going to plot inequalities. And then the day after, we'll take another video that shows you how to solve inequality word problems. And that should get done. We should get done with inequalities and probably move to absolute values after that before moving to other parts of the course. Thanks for your time. Hope to see you soon. Have a great day. Bye.